In this video, we're going to study complex rational expression. Complex rational expression or complex fraction is a rational expression in which the numerator n or denominator contains a rational expression. So let's look at the example of the rational expression. This is one of the example of a rational expression. The 1 over 3, the fraction 1 over 3, 1 over x, 1 over 9, 1 over x squared. These are called a minor rational expression, or just a minor fraction. This is a rational expression within the denominator or numerator. So it's now the easy way to see, I'm going to extend the main fraction bar a little bit longer, so you can see you have the rational expression in the numerator and we have a rational expression in the denominator. So this line we call main fraction bar. There are two methods to simplify a rational expression. Let's look at the first one. We follow these 3 steps here to help us to simplify a rational expression. Step 1, simplify the expression in the numerator into a single rational expression. Step 2, simplify the expression in the denominator into a single rational expression. And step 3, we put all of them together and we're going to divide. And to do this, we multiply the minor rational expression in the numerator by the reciprocal of the minor rational expression in the denominator. Simplify if possible. So let's look at the example number 1. I'm going to show you to simplify this by step by step. Let's look at step 1. Step 1 say that we need to simplify the numerator, and to do that, we look at we want to combine these two fractions here, and to do that, we look for LCD. The LCD for the minor fraction in the numerator is 3x. So I want this to become 3x and multiply by x in the top and the bottom, and I want this denominator become LCD, so we need to multiply by 3. So have x over 3x minus 3 over 3x. Now we can simplify this. I have x minus 3 over 3x. Step 2, we do exactly the same thing for the denominator. So in the denominator, let me draw longer. In the denominator, I have 1 over 9 and 1 over x squared. The LCD for the minor fraction in the denominator is 9x squared. Because 9 and x squared are unique, so we take all of them. Now we want 9 to become 9x squared, so we need to multiply x squared here and x squared in the top. For this one, we need to multiply by 9. So I have x squared over 9 x squared minus 9 over 9 x squared. So I have x squared minus 9 over the common denominator, which is 9x squared. Set 3. So I just copy and paste the problem down. Now we substitute the numerator from step 1. We got x minus 3 over 3x. And then for the denominator from step 2, we get x squared minus 9 over 9x squared. Then we take the numerator, divide by denominator. So let's rewrite that as x minus 3 over 3x divide x squared minus 9 over 9x squared. And we recognize we know how to do this. We keep the first rational expression, which is x minus 3, over 3x. We change this into multiplication by the reciprocal of the second one. So we have 9x squared over x squared minus 9. Please be careful, you always have to multiply, change to multiplication by the reciprocal of the second fraction. So now I'm going to factor out this denominator here. I have x minus 3 times x plus 3, x plus 3. Now how did I do it so fast? Because I remember I learned somewhere in the past the identity a squared minus b squared. So please remember this equal to a minus b times a plus b. In this case here, x is a and b is 3, because 9 can rewrite as 3 squared. So if you remember this identity, it will save you a lot of time. So now, divide out the common factor. I see that x minus 3 and x minus 3 are common factors, so divide out. What else can we do? We can see x here and x there. We can do the same, divide this out. Now we're left with only one x on the top. We can do the same thing for 3. Get 9 and 3 here and divide this out. So I have 1 left here and I have 3 left there. Pretty much that. So now multiply remaining factors. So this here, I actually have 1 times 3 times x. So we have 3x over 1 times x plus 3. So this is our answer. So now we're going to look at method number 2. I like method number 2 a lot because I found it easier, less work. So we have 3 steps. First step is determine the LCD of all minor rational expression within a complex rational expression. And then we multiply the numerator and denominator of the complex rational expression by LCD from step 1. Then step 3, we simplify. So let me show you the example. I'm going to show you the same example that from the example 1, so where you can compare which method you like. So first step, looking for LCD. Now, when I look at the problem, complex rational expression like this, I like to redraw the main fraction bar like really longer so I can see clearly. With this numerator here, denominator is way my mind won't get confused which switch. So we're looking for step 1, looking for the LCD for all minor fractions. So we look at the denominator 3, x, 9, and x squared. So the LCD, let's go over how to find LCD for this case. So 3 is just 3, x is x, 9 can rewrite as 3 squared, x squared. I can keep like that. So we take the unique factor, which is 3, and x plus 3, and is repeat. So this one here had a greatest exponent, so we pick that one. So as an x, we pick the x squared. So we have 9 x squared. So this is the LCD for all minor fraction. Step 2. Multiply the numerator and denominator by LCD, which is 9x squared. I just take 9x squared times the numerator here to rewrite everything over. And do the same thing for the denominator. Now, we use the distributive property to multiply in here. Okay. Remember, I cannot really add these two together because we don't have a common denominator. Yeah. So the only way to do it that's actually pretty much our goal is to simplify this by multiply the whole thing by LCD to clear out a fraction in the numerator. Yeah. To simplify. So we have x squared times 1 over 3 minus 9x squared times 1 over x. We do exactly the same for the denominator. Now we're going to simplify. 9 and 3 can cancel out. We have 3 left. This here we can cancel out the x. We have 1x left. Bottom, the 9 and the 9 cancel out. And the x squared and x squared gets cancelled out. So the next step is multiplying remaining factors. So 3 times x squared is 3x squared minus 9x over x squared minus 9. Our next step is to simplify, and to simplify a rational expression, we want to factor out. I see this here had a common factor of 3x, so I pull out 3x. At the bottom, once again, I recognize this as a squared minus b squared, which is factored out as x minus 3 times x plus 3. Now, we want to divide out a common factor because I see that x minus 3 factor and x minus 3 here are common. Divide out. So we're left with 3x over x plus 3. This is the answer, the exactly same answer that we did for method number by using method number 1.